Is R2 Swan a hidden threat? Scientists react. A gigantic object is hurtling through our solar system right now. It just appeared, glowing with a crazy green light and a massive tail. And the internet is completely freaking out. People are saying this is no ordinary comet. They're calling it an alien probe, a messenger from another world. Some are even saying its trajectory is way too close for comfort, and that it's going to hit us. The theories are insane: government cover-ups, secret signals, even links to ancient civilizations. This thing, called R2 Swan, has become a cosmic conspiracy, and people are losing their minds. So, is this just a harmless snowball, or is there something they're not telling us? But while everyone was panicking online, scientists were telling a completely different story. As the internet debated alien fortresses, scientists were decoding its light, calculating its path, and uncovering a truth that is way crazier than any conspiracy theory. So the real question is, what are the scientists actually saying? Tonight, we separate the science from the speculation. We're following the evidence to see what's really going on. We are putting all the crazy claims to the test. And in the end, we'll reveal the stunning truth behind Comet R2 Swan, a truth that is absolutely going to blow your mind. It all started on September 11th, 2025. This thing just appeared out of nowhere in a stream of data from a spacecraft. And it wasn't a NASA team that found it. It was a random amateur astronomer from Ukraine just looking through public photos. It was a discovery by one of us, which is pretty cool. Almost immediately, this comet caught everybody by surprise. It literally just popped into existence, already super close to the sun and blazing into view. Between August and September, it got insanely bright. This sudden appearance is what started all the speculation. How did our giant network of telescopes miss this thing? Astronomers later explained it was because the comet was hiding in the sun's glare. For weeks, it was hidden in plain sight. But for the internet, that simple answer wasn't good enough. It had to be a cover-up, and the theories got wild. The biggest one was the alien probe theory. People were convinced this was an artificial object, not a comet. They said its green glow was proof of an exotic plasma drive. Its tail was supposedly breathing. And get this, because another object was found around the same time. People said they were a team, a scout ship and a mothership. One viral video even called it a fortress with a nickel-cobalt armored hull, which is a claim with literally zero evidence. Hit that subscribe button and ring the bell so you don't miss the next great cosmic story. And if you want to support us even more, consider becoming a channel member. Just click the join button next to subscribe. Your support helps us bring you even more amazing space stories. The second huge theory was the hidden threat. Everyone was obsessed with the comet's orbit. Its closest approach is around October 20th, 2025, at a distance of 39 million kilometers, which sounds scary, but it's actually a massive miss. The internet, of course, twisted this into a near-disaster scenario. People were terrified that Earth would pass through the comet's hazardous debris field around October 6th. Then, an even crazier claim popped up that the James Webb Space Telescope had spotted artificial lights on the comet. This rumor went viral on social media, with people claiming it was a leak from inside sources. Finally, people started connecting it to mystical stuff. The comet's massive orbital period of over 22,000 years was linked to the end of the last ice age, asking if it was some kind of ancient celestial warning. This created a terrifying story of alien contact and a threat to all of humanity. But it was a story built on absolutely nothing. While millions were captivated by this, astronomers were busy getting the actual facts. And the facts told a very different story. While the internet was having a meltdown, the worldwide astronomy community was actually doing the work. They observed, they measured, and they calculated. And to understand their conclusions, you first have to know what a comet even is. So what is a comet? People call it a dirty snowball, and that's basically it. Comets are leftovers from when our solar system was formed 4.6 billion years ago. Just chunks of ice, dust, and rock. For most of their life, they're just frozen blocks floating in space. Most of these long-period comets, like R2 Swan, come from something called the Oort cloud. It's not a real cloud, but a giant, theoretical sphere of trillions of icy objects surrounding our solar system, way past Pluto. We've never seen it, but we know it's there. Every once in a while, something knocks one of these snowballs loose, and it starts a long journey toward our sun. As a comet gets close to the sun, things get crazy. The sun's heat makes the ice on the comet's core boil and turn directly into gas. This gas and dust forms a giant cloud around the core called the coma, which can get bigger than a planet. This also creates the iconic tails. Comets usually have two, and they always point away from the sun. The dust tail is made of solid particles, and it looks yellowish-white. The other is the ion tail. It's made of gas that gets zapped by the sun and glows blue or green. R2 Swan's bright green glow that had everyone freaking out? It's a classic sign of diatomic carbon breaking down in sunlight, a totally normal and understood thing for comets. So how do we know where it's going? When a new comet is found, astronomers everywhere track it. With just a few data points, NASA's Jet Propulsion Laboratory can calculate its entire orbit. For R2 Swan, they had its path locked down in just 2 days. These calculations confirmed its closest pass to Earth would be around October 20th or 21st, at a distance of 39 million kilometers. To put that in perspective, that's more than 100 times farther away than the Moon. There was never, at any point, a risk of collision. With that, we can destroy these myths one by one. Let's start with the alien probe. The main claim was that the comet behaved weirdly. But did it? Its sudden brightening is easily explained because it was hidden by the sun and then got super close to it. Comets also have random outbursts of brightness, and this one did too. This isn't alien engines, it's just what comets do. What about its strange, flat orbit? It's definitely unusual, but it's not a spaceship. For astronomers, it's a clue. An orbit like this means it had a massive gravitational smackdown with a giant planet, probably Jupiter. Jupiter's gravity can literally pull comets into weird orbits. That's not intelligent control, it's a gravitational scar. Then there's the claim of artificial signals detected by the James Webb Space Telescope. This is the easiest myth to bust. It's completely fake. No credible scientist has ever released data supporting this. A discovery this huge couldn't be kept secret. Even the theory that R2 Swan and 3I Atlas were a coordinated pair was easily disproven. Their paths show they came from completely different parts of the sky. Finally, what about the danger of Earth flying through the comet's debris on October 6th? The chance of that was always basically zero. The comet's path was going to pass 7 million kilometers above Earth's orbit at that point. Plus, the comet is gassy, not dusty, so it wasn't even leaving much of a debris trail. The threat was non-existent. The scientific investigation revealed one clear picture. C-2025 R2 Swan was a natural object, behaving exactly as a comet should, on a path that was never a threat. The mystery wasn't that the comet was strange. It was that its normal behavior was being twisted into something it wasn't. With all the crazy theories debunked, scientists were left with something way more exciting. A visitor from the dawn of our solar system, carrying secrets that have been frozen for billions of years. And what they figured out about C-2025 R2 Swan is truly mind-blowing. The first big clue came from its chemical fingerprint. By splitting its light into colors, astronomers can see what a comet is made of. R2 Swan was found to be incredibly rich in gases like carbon monoxide and nitrogen, but didn't have much dust. This explained why it was so bright and gassy. This chemical signature is huge. It suggests the comet formed in an extremely cold part of the early solar system. But the story gets even better. The insane amount of gas it was releasing, plus its weird, flat orbit, points to an unbelievable possibility. C-2025 R2 Swan might not just be a comet. It might be a fragment of a much, much larger object. The idea is that somewhere out past Neptune, there aren't just small comets, but massive icy bodies hundreds of kilometers across, maybe even the size of dwarf planets. If one of these giants broke apart, it would send fragments flying. And according to this new theory, R2 Swan is one of those fragments. Its crazy glow isn't just an old surface boiling away. It's fresh ice from the deep inside of a giant object, seeing the sun for the very first time and violently exploding into gas. It's like cracking open a geode that's been sealed for 4.5 billion years. If this is right, it changes everything. It means the Oort cloud could have a ton of massive, undiscovered objects. It means the comets we see might just be tiny splinters of giants still lurking in the dark. We're getting an up-close look at the raw material that worlds are made from. And the best part? You can see this for yourself. As of mid-October 2025, Comet R2 Swan is a perfect target for anyone with binoculars. Around October 20th and 21st, it will be at its closest and potentially its brightest. And it's happening during a new moon, so the sky will be super dark. This is perfect timing. So how can you see it? For most of October, look to the northern hemisphere in the evening, low on the southwestern horizon right after sunset. You'll need a clear view. It probably won't be visible with just your eyes, so your best tool will be a pair of binoculars or a small telescope. Download a stargazing app on your phone to find its exact location. Look for a faint, fuzzy patch of light. On October 13th and 14th, the comet passes near the bright star Sobek. Be patient. Get away from city lights. Let your eyes adjust and start your search. This journey from a crazy myth to a scientific marvel is why exploring the universe is so incredible. It's how we replace fear with understanding. If you love that journey as much as we do, subscribe to our channel right now. We explore the real science behind the headlines every single week. Hit that subscribe button and ring the bell so you don't miss the next great cosmic story. And if you want to support us even more, consider becoming a channel member. Just click the join button next to subscribe. Your support helps us bring you even more amazing space stories. Something strange is happening out there. R2 Swan isn't just a glowing green visitor passing through our solar system. It might actually be leaving a trail of subtle disruptions in its wake. No, not a sci-fi shockwave like in the movies, but something very real, something astronomers are now tracking with growing interest. This is what some are calling the shockwave effect. When a massive comet like R2 Swan streaks through the inner solar system, it doesn't travel quietly. Even though it's not a planet, its gravity, gas jets, and debris stream can create tiny ripples that affect the motion of nearby small bodies. Things like mini asteroids, meteoroid clusters, or other comet fragments. Now, to be clear, R2 Swan is not about to fling anything toward Earth. But the point is this. When something moves this fast and releases this much material, it interacts with its surroundings. Scientists call these effects non-gravitational perturbations, tiny pushes and pulls that slowly, but measurably, alter the paths of nearby objects. Picture this. R2 Swan is racing through space at tens of kilometers per second. As it heats up, it spews out jets of gas and dust like cosmic thrusters. This creates a streaming envelope of particles moving through the same region of space as other small objects. If a nearby asteroid or fragment drifts close to this flow, the constant drag and gravitational tug can gently change its speed or direction. It's not dramatic, but over time, those tiny changes can add up. In a cosmic sense, R2 Swan is like a giant ship cutting through a calm ocean, leaving behind a wake that other boats drift into. Astronomers are now running orbital simulations to see if this passing comet could nudge smaller, previously unremarkable objects into slightly different orbits. Most of these will remain harmless. But here's the exciting part. These shifts act like fingerprints, revealing hidden clusters of rocks and fragments we didn't even know were there. And even more interesting, tracking this shockwave could help scientists map regions of space near R2 Swan's path, discovering weakly bound debris fields or ancient fragments that might have been dormant for centuries. This isn't the first time something like this has happened. Historically, passing comets have been linked to meteor streams, faint dust rings, and even the creation of entirely new meteor showers decades later. So even after R2 Swan disappears into the darkness, its gravitational fingerprints might remain, subtly shaping local space traffic. This means R2 Swan isn't just a glowing visitor, it's a moving force, leaving a legacy long after its flyby. So, while the internet was busy calling it an alien probe, scientists are watching something far more fascinating: how one comet can quietly reshape its surroundings. And if their predictions are right, we might actually see the results of these changes in the night sky in the years to come. In the next episode, we'll dive into the hunt for its mysterious parent body, the lost giant that R2 Swan may have once belonged to. In the end, Comet C-2025 R2 Swan was never a threat. It wasn't an alien messenger. All the fear around it was just a reflection of us, not the comet. In the silence of space, it's easy to invent scary stories. But the real story of R2 Swan, the one from scientists, is so much cooler. This comet is a time capsule, a physical piece of the cloud that formed our sun and our planets. Its chemistry and orbit tell a crazy story of a colossal parent body, a lost giant from the edge of our solar system that shattered a long time ago. We are literally witnessing a ghost, a fragment of a history we're just starting to understand. The journey of this comet is the perfect example of science in action. It started with a mystery, led to insane speculation, but through careful work, that speculation was replaced by a powerful scientific discovery. We learned that what looked like a threat was actually an opportunity. What was framed as an alien mystery was a message from our own past. Once it passes us, R2 Swan is heading back into the darkness, and it won't return for thousands of years. We have this one short window to see it and learn from it. So, when you look up at the night sky this month, searching for that faint, fuzzy patch of light, remember what you're really seeing. You're not looking at a mystery born of fear. You're looking at evidence. You are seeing a beautiful, natural phenomenon that connects us directly to the birth of our world. And you're part of the awesome human tradition of looking up and choosing wonder over worry and science over superstition.
In the cold, dark emptiness of space, where silence stretches for billions of miles, something impossible just happened. The James Webb Space Telescope, the most powerful eye humanity has ever opened to the cosmos, caught a glimpse of something it was never even built to see. As it scanned a quiet patch of the sky, its instruments picked up a series of faint, structured luminous signals coming from a tiny, icy wanderer, R2 Swan. To most astronomers, this object was nothing more than a frozen relic, a silent traveler drifting through the solar system with no story to tell. But what Webb saw shattered that belief in an instant. This wasn't a random glimmer or a background star flicker. The light had precision. It was rhythmic, patterned, almost like a heartbeat pulsing through the void. The telescope's data showed something that didn't match the usual cosmic suspects. Not starlight, not a reflection, not even the faint glow of outgassing ice. It was structured, deliberate. And here's where it gets even stranger. Webb wasn't even supposed to detect this kind of signal. Its instruments are tuned to observe the earliest galaxies, the birth of stars, the faint whispers of the Big Bang itself. Yet it still caught these lights, like a message accidentally overheard in the dark. Imagine listening to static and suddenly hearing a clear whisper saying, "I'm here." That's what it felt like for the scientists who saw the data. Every line, every spike, every tiny fluctuation pointed to something that wasn't just there by chance. And as they dug deeper, they realized the lights weren't flickering once and vanishing. They were persistent, they were real, and they were coming from R2 Swan, a place no one had ever expected anything extraordinary to happen. Why would an interstellar object this small emit a signal with such precision? Who or what could be behind it? Or could this be something far older than us, finally revealing itself after drifting through the void for ages? This single detection has already cracked open doors no one thought to knock on. And the closer astronomers looked, the stranger it got. The first detection was strange enough to raise eyebrows. But the next revelation stopped the entire research team in their tracks. When scientists ran Webb's data through deeper spectral analysis, what emerged wasn't some chaotic light echo from a star or the random shimmer of cosmic ice. No. This was something with structure, with precision. The light from R2 Swan didn't behave like anything naturally found in the void. Instead of a messy, scattered spectrum, it revealed narrow-band, rhythmic pulses, clean, controlled bursts that lined up like a digital fingerprint. The signal looked eerily familiar. In fact, the spectral pattern mirrored something humanity itself has created: engineered illumination, remarkably close to the signature of modern LED lights. And here's the unsettling part. No known comet, asteroid, or fragment in the solar system emits light in this way. Natural reflections scatter. They fade unevenly. They twist with the object's rotation. But this signal repeated with mechanical accuracy, as if a hidden system on that icy rock was switching on and off like a coded beacon. At first, some astronomers thought it might be an artifact in the data. Maybe a glitch, a cosmic ray, or a reflection from Webb itself. But after 3 separate teams replicated the analysis with different instruments and timestamps, the same rhythmic pulses returned every single time. It was almost like someone had left a light switched on out there, waiting to be found. What really sent a chill down scientists' spines was the spacing of the pulses. They were too clean, too stable, the kind of precision that even many human-made devices struggle to maintain in deep space. It was as if the source wasn't just emitting light, it was transmitting something. If this signal is truly artificial, it means R2 Swan is no longer just a cometary fragment. It's something far more mysterious. Maybe a vessel, maybe a beacon, maybe a relic. And with every calculation, the probability of a natural explanation shrank further. The Webb telescope wasn't just observing the universe anymore. It may have stumbled on something trying to be seen. By now, what started as a faint glimmer in the darkness had turned into something far more calculated, almost engineered. When researchers broke the signal down frame by frame, what they discovered silenced the entire control room. These lights weren't scattered. They weren't drifting randomly like sunlight bouncing off ice. They were organized. Each luminous burst followed a precise interval, repeating like the tick of a cosmic clock. And then came the detail that made even the most skeptical scientists lean closer. The lights were arranged in structured arcs, forming clean, curved alignments that looked far too intentional to be a product of chance. Comets don't do this. Asteroids don't do this. Nothing drifting alone through the void organizes light in perfect geometries. Yet R2 Swan did. It was as if the illumination was being orchestrated, controlled by some hidden mechanism. Beneath its icy surface, one team overlaid the light patterns on a 3D model of the object and realized the arcs weren't random at all. They seemed to follow the curvature of the comet's body, almost like panels or rings placed with purpose. The pulse intervals were synchronized, as if each segment of the arc was working in unison, responding to the same invisible rhythm. And the longer the telescope watched, the more undeniable the precision became. Even as R2 Swan rotated, the arcs didn't flicker out of sync. They adapted, adjusted, maintained formation. This level of control hinted at something extraordinary. A technology designed not just to exist in deep space, but to function flawlessly for possibly centuries. Whether it's still active, or simply repeating a program left behind long ago, no one knows. But one thing was clear to the teams watching the data unfold: this was not nature at work. This was design. And somewhere out there, in the frozen darkness of R2 Swan, someone or something might have built it. When the first patterns were revealed, the scientific world was split down the middle. Some were convinced they were looking at a historic breakthrough, while others insisted it had to be a technical error, a trick of the instruments, a glitch, or some stray interference from Earth or the telescope itself. But what happened next erased all doubt. NASA scheduled multiple follow-up observations, each carefully designed to rule out every possible false signal. Webb's sensors were recalibrated. Its orientation was changed. The team adjusted its filters, its tracking, even the angle of observation. If the signal was nothing more than a fluke, it would have disappeared the moment any of those variables changed. But it didn't. Every single observation, from different positions and at different times, returned the same rhythmic pulses. The light arcs still held their shape. The intervals never drifted. It was like the source was locked in place, unwavering and alive. To push the test even further, astronomers coordinated with ground-based telescopes and other orbiting observatories. And one by one, the results came back identical. R2 Swan was still pulsing. It wasn't a one-time flash or a background reflection. It was a persistent signal, repeating itself with flawless precision, no matter how many times or ways they tried to break it. Hit that subscribe button and ring the bell so you don't miss the next great cosmic story. And if you want to support us even more, consider becoming a channel member. Just click the join button next to subscribe. Your support helps us bring you even more amazing space stories. The air inside the mission control room was heavy. Veteran scientists who had spent their entire lives chasing faint, uncertain signals were now staring at a pattern that refused to vanish. That kind of consistency doesn't happen by accident. Some quietly whispered the word they'd avoided since the beginning: artificial. What made it even more chilling was how calm the signal seemed. It didn't react to observation, didn't flare, didn't fade. It simply stayed, steady, structured, and waiting. And with every repeated measurement, confidence grew. This wasn't an error. This wasn't noise. This was real. And it was out there, pulsing from a cold, silent fragment no one had paid attention to before. By the time the verification phase ended, the question was no longer whether the signal was real. It was what it meant. And that's where the weight of the discovery truly hit. Because if these lights were artificial, then everything we thought we understood about this quiet piece of rock called R2 Swan was about to be turned upside down. A comet emitting engineered. Light suggests one of three possibilities, and none of them are small. The first is the most unsettling. R2 Swan might not be a comet at all. Its frozen shell could be a disguise, masking something technological beneath the surface. Imagine an ancient vessel wrapped in ice, drifting silently through space for who knows how long, carrying secrets older than our civilization itself. If that's the case, then the lights might not be a signal at all. They could be part of its navigation or life support system, still functioning long after its creators are gone. The second possibility: R2 Swan is acting as a beacon. The light pulses are too clean and deliberate to be accidental. Perhaps this object isn't trying to hide. It's trying to be found. A fixed, repeating signal could be a cosmic marker, like a lighthouse in the dark, designed to guide or alert something, or someone. And the third possibility is the most haunting of all. R2 Swan could be an ancient artifact, a remnant from a civilization that no longer exists, a technology built not to travel, but to endure. It might have been drifting through the void for thousands, maybe millions of years, waiting for another intelligent species to stumble upon it. And that species is us. For astronomers, the implications are staggering. If this is technological, it means we're not alone, and we never have been. It also means humanity just found the first physical evidence of something alien not light years away, but right here, inside our own solar system. This discovery forces a new question, one that no telescope can answer. Was it left here intentionally? And if it was, why now? For decades, the search for extraterrestrial intelligence, SETI, has followed a familiar path. Point the antennas skyward, scan for radio signals, and hope for a faint whisper from a distant star. But R2 Swan just broke that script. If the lights on this object are truly artificial, then humanity may have been listening to the wrong language all along. The signal wasn't a broadcast. It wasn't a transmission across the stars. It was light, steady, structured, and incredibly simple. And that's exactly what makes it so powerful. Light doesn't degrade like radio waves. It doesn't need complex receivers. It can endure for centuries, silently flashing a message to anyone capable of noticing it. This is the beginning of a new chapter in how we search for intelligent life. Instead of waiting for civilizations to call out to us, we may need to start looking for their footprints, the silent markers they leave behind. A glowing arc on a comet, a rhythmic beacon on an asteroid, a quiet flare on a moon no one has visited yet. Scientists are already calling this a techno-signature paradigm shift. For the first time, SETI's focus is expanding beyond radio telescopes to include light-based markers, technologies that are cheap, durable, and universal. Because while advanced civilizations might build massive structures or send complex messages, they may also rely on the simplest signal of all: light. And that's the terrifying beauty of it. These markers could have been blinking in our sky for centuries, maybe even longer, and we never looked closely enough to notice. R2 Swan might just be the first of many. What's even more haunting is this: if light is their language, then we've already been surrounded by their whispers. We just didn't know how to listen. As scientists continued to examine the data, a chilling possibility began to take shape. What if this isn't something alive, but something left behind? The more researchers studied the precision and stability of the light pulses, the more it looked less like an active broadcast and more like a system on autopilot, something built to outlast its makers. Imagine a civilization, long vanished, sending its final trace into the void. Not a message of words, but a machine that simply endures. R2 Swan may not be transmitting to anyone. It might just be waiting, a frozen monument drifting across the stars, carrying with it the last heartbeat of a species we've never met. The lights are too methodical, too clean, and too unchanging to seem reactive. No fluctuations, no irregular spikes. It's as if the object has been performing the same task for ages, like an ancient clock still ticking in an abandoned world. This theory paints R2 Swan as a cosmic time capsule. Perhaps its creators knew their civilization wouldn't last forever, but they wanted something to survive them. A beacon, a signature, a way of saying, "We were here." And if this is true, then what Webb has detected isn't just technology. It's memory. The memory of an intelligence that may have burned bright long before humanity took its first breath. The weight of that idea is enormous, because it means our solar system may not just be a place of planets and comets. It may also be a museum of forgotten civilizations, their relics silently drifting unnoticed until someone finally looks. And Webb may have just opened the door to the first exhibit. When the first whispers of artificial light on R2 Swan leaked into the scientific community, it didn't just spark curiosity. It shook the foundations of how we see ourselves in the cosmos. A single detection, a simple rhythmic glow, carries the power to rewrite the story of humanity. For astronomy, this is nothing short of revolutionary. For over a century, the search for life beyond Earth has been built on probabilities, theories, and distant hopes. But an object inside our own solar system carrying signs of engineered technology would transform that search from speculation into direct evidence. It would force science to expand its boundaries, merging astrophysics with engineering, archaeology, and even linguistics as experts try to decipher what exactly has been found. And that's just the scientific wave. The cultural shock would be even greater. Humanity has long lived with the quiet belief that we are alone, or at least that no one has left us a message nearby. That illusion would shatter overnight. Every school book, every theory about humanity's uniqueness, every cultural myth about isolation in the stars would need to be rewritten. New fields would rise. Astroarchaeology, the study of ancient extraterrestrial artifacts, would become a reality, not a dream. Historians, linguists, engineers, and scientists would work side by side, not to imagine alien civilizations, but to study the traces they left behind. Religions, philosophies, and worldviews would be tested like never before. Some would see this as proof of cosmic kinship. Others might view it with fear or even denial, but no one would remain untouched. Humanity would be forced to face a new truth. We were never truly alone. And perhaps the most profound shift would come not from the light itself, but from what it implies, that intelligence existed out there long before us, and may still exist somewhere in the dark, watching. With the undeniable evidence of artificial lights on R2 Swan, humanity faces a question that is as thrilling as it is terrifying. What comes next? The object is small, icy, and unassuming, yet it may hold the first tangible evidence of extraterrestrial intelligence. The natural response for scientists and engineers is to study it up close. Robotic probes, advanced sensors, even miniature landers could be sent to scan its surface, measure the pulses of its lights, and try to peer beneath the ice for hidden mechanisms. The potential discoveries are staggering. Technology older than human civilization, energy systems beyond our comprehension, or even clues about the civilization that left it behind. But with this opportunity comes a towering ethical dilemma. If the lights are still active, are we justified in disturbing them? Could a misstep erase centuries or millennia of legacy left deliberately for others to discover? Perhaps R2 Swan was designed as a time capsule, a quiet monument drifting through space, intended to survive the rise and fall of its creators. To touch it, even with robotic instruments, could be akin to disturbing a grave, a relic of a civilization long gone. Scientists, ethicists, and policymakers are now forced to ask, do we have the right to explore it, or is restraint a form of respect? The implications are not merely philosophical. Any mission would demand unprecedented international collaboration. Nations, private companies, and space agencies would need to align on protocol, access, and purpose. The object exists in a shared cosmic neighborhood, outside the ownership of any single entity. One misstep could trigger disputes over technological secrets, scientific priority, or even perceived sovereignty. R2 Swan may be small, but the stage it has set is gigantic. There's also the human dimension. Imagine witnessing your first close-up image of a comet with engineered lights on its surface, knowing that it may represent intelligence far older and more advanced than humanity. How do we process that psychologically? How do societies cope with the proof that we are not alone, that the universe harbors minds capable of design and creation beyond our experience? The questions cascade endlessly. Should we attempt to interact? Should we simply observe? Could we learn without interference? This tiny, icy fragment has suddenly become a mirror for humanity's wisdom, curiosity, and restraint. The decisions we make now, whether to send probes, how to study it, and how to interpret what we find, could define the next era of human exploration. R2 Swan is no longer just a comet. It is a test of our readiness to encounter intelligence beyond Earth, a puzzle demanding caution, courage, and imagination in equal measure. Every pulse of light it emits challenges us. Are we ready to step into a universe where we are not alone? Before you go, don't miss what comes next. Click on the video in the end screen to continue exploring the mysteries of the universe. See more mind-blowing interstellar discoveries? Trust me, you'll want to watch every second. The journey is only getting wilder.